Welcome students to your new video. So my name is Kamini Joshi and I am an assistant professor in CSE department in Chandigarh University. And today's topic of our video will be number system in computer. All right. So as throughout this course, you will be studying programming and you know that those programs will be written on the computer. Using computer, you will do that, right? So understanding that what number system, the architecture of a computer understands is very important for us as beginners, right? So today's topic is going to focus on that what are number systems, how many types of number systems we'll have, okay, and most importantly, if you want to convert a number system to another, how it will be done, what formulas will be used, what procedures will be used to do that. So uh, give you more brief about the number systems. So we have studied number system in mathematics. So when we used to study in school, we understood that there are many types of numbers. We have real numbers, whole numbers, integers are there. Similarly, when we work on a computer also works on a number system, and mainly we work on four number systems. That would be binary, decimal, octal, and hexadecimal. Now, the point comes that how we will come to know when we are writing a number, how we will come to know whether that number is a binary number, whether that number is a octal, a decimal, or a hexadecimal. So two factors comes into the picture. So those two factors will be, the first is the base of the number. So whenever we write a number, we mention its base. So base will describe that what type of number that is. And second, the range of digits that we use in that. Okay. So now I'm going to share my screen with you all and we'll understand that what is this base and range we are talking about and how a computer or when we look into a number, we are going to distinguish between them. Right. So let me share my screen with you all. So I hope that would be visible to you. So as I've told you, there are four main types. So the first is a decimal. And decimal number system is the most used number system in programming, or you can say in the form of computers. The base of this number will be 10. When base of any number is 10, that would be considered as a decimal number, and the range of number which will be used to represent a decimal will be, I am going to use a number in between 0 to 9. So if I am writing 18, and then I'll write its base is 10, it becomes a decimal number. So this is my base, right? And the number that I have used, 1 and 8, this both numbers lies in the range of 0 to 9. So this is a decimal number. Now point comes that why its base is 10. How we came to know. So can you count the numbers? If you will count from 0 to 9, how many numbers are coming? 10. That is why its base will be 10. Similarly, the other number system that we have is a binary number system. Its base will be 2 and it is only represented by using two digits, that is 0 and 1. So any number which will be represented by 0 and 1 and its base will be 2, that number is counted as a binary number. Because if I'll write this number, let's suppose 101, 101 number can fall under the category of decimal also, and it can count under the category of binary also. But what describes the base of this number, if written as 2, it becomes a binary number. Instead, if I write 101 and I'll write its base as 10, in that case, it will become a decimal number. And binary is the most important out of them when we talk about a computer architecture, because If you know this thing, that a computer understands binary, anything, any operation that you will do on your computer, in the end that instruction will be converted into a binary code, because my computer doesn't understand English, it doesn't understand any other language or any other number system. Instead, guys, it is going to understand the binary number system only. Similarly, talking about the third number system that we have is octal. So we know that octal stands for 8. So base of this number will be 8, and it will be, the range will be from 0 to 7. So if I'll take a number, let's suppose 0, 1 and 7. Now 107 number can fall under decimal also. But how we will come to know it is an octal number? When its base will be written as 8. Similarly, if we talk about a hexadecimal number, its base is 16. So over here, how do we represent? It takes 16 numbers into account, but we don't mention them from 0 to 15. How do we mention? The first 10 numbers will be represented from 0 to 9. Then 10 will be represented by A. Similarly, 11 will be represented by B. Similarly, up to 15, 15 will be represented by F. So if I want to represent a hexadecimal number, let's suppose A2. So this is a hexadecimal number. Its base will be 16. Over here, A will be representing what? A will be representing 10. So these were the types of number systems that we have. So now you can see the examples over here also. So binary base would be 2. It will use 0 to 1. So they have given us the example. Similarly, octal base will be 8. I will use any number in between 0 to 7. So its base will be 8. Similarly, for decimal, it will be 10. And for hexadecimal, it will be 16, but 10 will be represented by A, then 11 by B, 12, 13, 14, and 15. In total, how many numbers will be there? In total, I have 16 numbers, right? So now this was the base of the number system that we had. Now let's understand that how you can convert a number which is present in a particular number system to another. Because whenever we write anything on the system, okay, let's suppose I'm writing a program where I took an integer of variable n. I gave it a value 29. But my computer doesn't understand 29, and let's suppose it is a decimal number. When this number will be taken into the RAM, or it will be stored in the RAM, its binary representation will be stored. So how computer will convert that into a binary number, or similarly how a decimal number will be converted into octal and others? So we are going to understand that. So let's talk about the very first conversion. The first conversion that we are going to study is, so if you have a decimal number, how you are going to convert that decimal number into other bases, be it a binary, be it octal or hexadecimal. So very simple method we have. We have to perform two steps, either to convert it into binary, to octal or hexadecimal. So the first step will be, I am going to take the number, okay, and I am going to divide that number by the base of the resultant. So let's suppose 29 is the number. I want to convert it into a binary number. So the base of binary is 2. I will take this number divided by 29, and we are going to store the remainder. And we will keep on doing this operation until and unless we are not getting a 0, and we will keep on storing the remainders. Then we are going to label two things. So this will be step number 1. We are going to label two things. So the first remainder will be labeled as LSB, and the last remainder that we got will be labeled as MSB, where LSB stands for the least significant bit and the MSB is going to stand for most significant bit. Then we will start from the most significant bit to the last significant bit, and we are just going to write the number. So let's understand it through an example now. So, bache, over here, what I am doing, I am taking a decimal number and I will convert this decimal number into a binary number. So, my decimal number is what? It is a, it is 29. So, I took 29, right? Then I divided 29 by 2. My quotient came out to be 14 and my remainder came out to be 1. So, I stored it. I again took 14, divided it by 2. Why am I dividing it by 2? Because the formula says that you have to keep on dividing the number by the base of the resultant until and unless we are not getting a 0. Right? So I took 14, then 7, remainder came out to be 0. Then I took 17, 7, then I divided it by 2. Again, 3 was the value and the remainder which came out to be 1. Similarly, I divided it by 3. Then I took 3 divided by 2. So 1 was my remainder and 1 was my quotient. I took 1 divided by 2. Remainder came out to be 1 and the quotient came out to be 0. So quotient 0, we stopped here. Now what I have told you, the second step is the last remainder will be labeled as the most significant bit and the first remainder will be labeled as a least significant bit, right? So now how am I going to write it? Starting from the most significant bit to the LSB. So 1, 1, 1, 0, 2, sorry, 0, 1, its base will be 2 and we have converted it into binary. So this is the simplest way to convert a decimal into a binary base. So now you can take any number, but the point comes that you have to keep on dividing that number by 2 until and unless we are getting a 0. Label MSB, LSB, then just start writing the number starting from MSB to LSB and mention the base. So that is it for converting the decimal into binary. Now let's understand that if you have a decimal number, how you will convert it into octals. The base of octal is 8, right? I took 200. 200 I need to convert it into the octal. I'll divide it by 8. My quotient came out to be 25. 25 eights are 200. So my remainder came out to be 0. Again, I divided it by 2, right? So 8 threes are 24. 1 was the remainder. I got 3, divided it by, remainder gave me 3 and quotient 0, stopped here. Again, this is my MSB and the first digit was my LSB. Even if it is coming out to be 0, we have to mention it, right? So again, 310 base 18 is the conversion. So if you will have a number which is 200 in decimal, that would be represented as 310 in octal. So this is how you are going to convert it. Then guys, let's understand that how you will convert a decimal into a hexadecimal. Same process is there, but the base changed. Now the base is 16. 16 we took, I am taking a number 450. Okay, so what I did over here, I divided 450 by 16. So 28 came out here and 2 was kept as remainder. So we stored it, right? Again, I divided it over here. So 16 ones are 16, 12 was the remainder. Then 1 divided, then 1 came out to be remainder and quotient 0. We stopped here. But now the point comes is we have already understood this thing that we are not going to write 12. Instead, how 12 is represented by C. So that is why we will not write 1 12 or 2. This is wrong. Writing this is incorrect. Instead, we'll write 1. 12 is represented as C and then 2. So this will be my represented for the hexadecimal. So now up to this point, we have understood that if you have a decimal number, how the decimal number will be converted into other bases. And in this video, we are going to discuss one or two more conversions. So let's discuss the next one. So the next one is that if you have a binary number, how that binary number will be converted into other bases, be it decimal, be it octal, or be it hexadecimal. So in this, the process will not be same. The process that I will use to convert a binary to decimal will be different, but for octal and hexadecimal, it will be kind of similar, right? So what we are going to do when we are converting a decimal from a binary, first of all, I am going to write the number. Okay, just look at the example directly. What I'll do, I'll just write the number and I will multiply each digit with a power of 2 starting from 0. That means the first number will be multiplied by 2 raised to power 0 because 2 is the base of binary. Then the second number will be multiplied by 2 raised to power 1. Then 2 raised to power 2, 2 raised to power 3, 4, 5, 6, and 7 up to last number. Then we are going to calculate it and we will add all these numbers. After the addition, I will get its solution. So the solution which I came or got over here was 217. Its base will be 10. Again, I am repeating, write the number, start from the least significant bit, multiply it with 2 raised to power 0, then 2 raised to power 1, up to 2 raised to power 7, because there were 8 digits in this. Then just add the resultant, that will give you a decimal. Similarly, if you want to convert a binary into, let's suppose, a octal, what needs to be done is, one of the method to do that operation is take the number in similar way. So the base of octal is 8, just multiply that number with the powers of 8. 8 raised to power 0, 8 raised to power 1, 2, 3 up to 7. Add them, that will give you the octal conversion. And if you want to do it with hexadecimal, similarly 16 powers will be taken. That is one way. But I'll give you a simplest way to do it. Okay. So if you want to convert a number which is the binary to a octal, simply what you do, just make the pairs of the binary number in the set of 3, in the group of 3, and then write the correspondence value for that, the decimal conversion for that. So if I had a number, let's suppose this, so I will start from the least significant bit. I will make a group of 3. So first group, second group, and the third group. Third group contains only one twice. So these are only 2 numbers. So what am I going to do? I will add a 0 in front of it. Then I will take them and I'm going to convert them individually into its decimal conversion. So 1001 will be 5, 100 will be represented as 4, and 011 will be represented as 3. So I'll combine them. This becomes the octal conversion. How I did it right now, if it is not clear to you, if I'll take 1001 or 101 specifically, I want to convert it into decimal, what I'll do? This 1 will be multiplied by 2 raised to power 0, right? This will be multiplied by 2 raised to power 1, and this will be multiplied by 2 raised to power 2. So what will be my answer? This will give me 4. This will be added to a 0, and the next value will be 1. So what came out? 5. Similarly, for others also, you can do that. So this is the easiest way. Just remember that how you are going to convert a binary into decimal. You have start from the least significant bit and just take the groups of three numbers. If the numbers are 2 or 1, you have to add those many zeros to it, right? Similarly, if we talk about converting a binary into hexadecimal, same process will be there, guys, but now the grouping will be in 4. Okay, so what I'll do, let's suppose I have this number in binary, I want to convert it into hexadecimal. So I'll take this number, just a second. So first group, starting from the least significant bit, first 4, then next 4. So when I'll convert this into decimal again, this will give me what? 5, and this will give me E. That means it will be coming out as 14. So 14 is represented as E. So my answer will be E5 base 16. So this is how you are going to convert a binary into hexadecimal. Okay. So in this video, what we studied is that how a number system is going to work, and if you have a number which is present in a specific number system, how its conversion will be done. Okay, so I hope you enjoyed this session. Okay, thank you so much. So I'll be ending this video over here only. Have a great day.